So, yeah, that's good. We've almost got 200. That's good already. And it always increases. We'll give it another minute or two. Now I know if I accidentally start it, I can just let it go. Okay, it's 11. I'll go ahead and start. I want to have the nice big introduction with the session starting now. Obviously, you've heard I started the session early, so you've probably been listening to us. But we're going to start the February session of DBAFundamentals. And today we have Gail Shaw presenting performance methodology as Gail sees it. We intend to have several other sessions this year from noted people to where they specifically do a session. I'm sure they're going to use it again, but they'll do it specifically for us, just going over their performance methodology. I found that you can learn a lot from looking at how other people solve problems, and I think it's a neat way to look into it. I know other people have done this, but I thought it doesn't hurt to have extra ones out there. My name is Steve Cantrell. I'm the co-leader of the DBAFundamentals virtual chapter, and the session is being recorded and will be available in our archive session within a few days. And Gail should get us the scripts and slides, and if she has scripts, and we'll send them along. Along the way, if you want to record something, this is something I found out a couple of months ago. Up at the top right-hand side of your screen, there's a little camera. If you will hit on that, it'll record a view of the screen. If you've got something you want to write down or anything like that, that's always helpful. Virtual chapters there's tons of virtual chapters with Pass now, and there's tons of great recorded information out there. I've got a few selected ones that are coming up. Our sister chapter, DBA Down Under, will be doing one on SQL Server encryption next week with Ben Miller on the 9th, which that's Brisbane time. In Australia and here in the United States, that's 7:30 or 8:30 Central. Women's in Technology virtual chapter. It's a great chapter. We'll be doing a presentation this Thursday, February the 4th at 12 p.m. on Tech Girls Tech Shops. Run a tech workshop for girls. I have 3 granddaughters, and one of them's on the way. And I really would love for them to be into technical work. And as we all know, that there's not enough women in tech. And this is a nice way to help introduce girls at middle schools and other meetings. And it's a tech workshop, and all of it's packaged together. The BI chapter will be doing Getting Started with Power BI and Time Calculations on February the 9th with Dustin Ryan. And we have another thing that we're going to do this year. It's going to be sort of a series of presentations. They're going to be given at odd times. Since we're a fundamental chapter, people at a certain point get to where they want to prove what they know. Now, certifications aren't the be-all, end-all, but they do help you at least get past the front end when you're talking to somebody and you're looking for another job, and it allows you to prove some of what you know, and at least you've covered this stuff and you've been able to pass tests. Some people say I'm good at passing tests. It's something worthwhile. We have talked to one of the main guys at Microsoft that actually helped write a lot of the test, and he's going to give us a first presentation with overall Microsoft certifications, and we're going to let the we're going to co-host that with the professional development group. That is tentatively set for March the 15th. After that, through the rest of the year, we're going to have a session over 7461 T-SQL, 7462, the administration MCS A certification, and at the end of the probably the first of the third quarter, there's a lot of changes coming to the BI certification, and we're going to have that one. All that information isn't together yet, so that's something coming up. Okay, that's all the information I want to go over. Let's get to Gail. Gail Shaw, if you don't already know her, is a database specialist from Johannesburg, South Africa, specializing in performance tuning and database optimization. She works for Entelect, a medium-sized custom software development house. She's a frequent poster on the SQL Server Central forums and writes for SimpleTalk. She's an MVP for SQL Server and holds the Microsoft Certified Master certification for SQL Server. Over to you now, Gail.
Thank you. Good evening, everybody. Well, it's evening where I am, so as far as I'm concerned, it's evening. Right, so we're going to have a look this evening at a performance tuning methodology. And shameless self-promotion, this is what I do for a living, mostly. I think I would estimate that I spend probably half my time on any average month doing performance tuning of client systems. Big, small, OLTP, I've even done a few data warehouses recently. For badly performing systems are not hard to find. Unfortunately, it's also not hard to find people who claim they can tune your systems for you. Lots of consulting companies will happily tell you they can do that, and sometimes they even can. Not always. I'll have a few horror stories as we go through tonight. What Steve asked me to do this evening, and what I'm going to spend the next roughly 40 minutes doing, is taking you through my methodology for performance tuning a server that I do not know at all. So this will be a new server. Client is called performing badly, please help. This is my general methodology, start to finish, how I approach badly performing servers for clients. So, if I can get my mouse working. First up, my general approach for performance tuning is a methodical scientific approach. I do not make random guesses. I do not tune stuff just based on which way the wind is blowing. I don't pick stuff at random or because I like the way the procedure name is spelt to try and work on it. I use a very scientific, very data-driven approach. I will gather numbers. I will analyze the results I get, and based on what those numbers tell me, I will decide how to proceed. What this means is that I'm not wasting any time looking at things which are not a problem. I'm going to approach the server with no idea what's wrong with it, with no early conclusions, with no preconceptions. I'm not going to go to the server saying, well, it's clearly X, before I've even looked at it. What I'm going to show you tonight is some of the numbers I look at, some of the interpretations I can make from them. There's going to be a lot of stuff left out of this because, to be honest, if I was going to teach this in a huge amount of detail, we'd be here all week. While some of you would enjoy that, my boss kind of expects me to be at work tomorrow. So I'm going to this is going to be high level. I will put some of this stuff up on my blog in months to come. It's not going to be in a few weeks. I have written an article on some of this already on SimpleTalk. It's quite an old one. I'll probably look at doing some additional articles going into more detail. But the thing to note for the general approach is we are looking at hard numbers. We are looking at defined metrics. We are not making any guesses. We're not jumping to conclusions. And we are absolutely not making knee-jerk fixes based on single data points or invalid conclusions. And as we go through, I'll explain some of the cases I've seen of knee-jerk type fixes based on usually misunderstanding of what things are saying. That's the high-level plan for tonight. Steve, any questions at this point?
No.
No, okay, good. So what I will start with when I'm looking at a server are the Perfmon counters. This is Performance Monitor. These will not tell me what I need to do. These will give me a general health of the server. They'll give me a general feel for what is wrong with the server at a high level. These will tell me whether I'm probably looking at CPU bottleneck, probably looking at an I/O bottleneck, probably looking at not enough memory, something in that area. One thing to bear in mind is that the counters, Perfmon counters in general, do not have good or bad values. They don't have hard thresholds. They don't have values where if it's below it's good and if it's above it's bad. And this actually may come as a surprise to people who use SCOM to monitor, because SCOM is System Center Operations Manager. SCOM is very prone to giving alerts. Such and such counter is over 400. Okay, and I keep seeing forum posts from people who will ask, SCOM is sending this alert, and it may be something like page life expectancy is under 900, and they say, what does this mean? What am I supposed to do? The short answer is it doesn't alone mean anything, and alone it cannot be used to determine what to do. It's a problem with some of the performance monitoring tools. They'll tell you things that aren't of much value, because in general the counters, whether the values are high or low, will give you an indication as to what's wrong with the server. But a difference of, say, 998 versus 1010 is not meaningful. If it's a counter that should be high, then 990, 1000, 1010, those are almost all the same. If it's a counter that's supposed to be low, same thing. It's not a case that there's a threshold where anything above it is good and anything below it is bad. They don't work that way. What's generally important with the Perfmon counters, and this is more important if you're looking at a server that you are responsible for or that you're working with all the time, the most important thing is the trends. Is this counter value lower than it usually is? Is it higher than it usually is? Because those kind of changes will give you an indication that something's going wrong. Now, in my case, when I'm walking into a scenario with a server I've never seen before, I can't use those trends because most people do not have Perfmon monitoring on their servers by default. Sorry. And so I'm going to look at Perfmon counters just to give me a general feel for the health of the server, a general feel for how it's behaving in certain areas. Most of the counters have to be looked at in relation to other ones. So you can't look at one counter and make a conclusion. Look at a whole bunch of them, and it might give you an area to start looking at. It's unlikely to give you a thing to do based on a single counter.
Gail, something, and I think it's the session. Your voice is wavering, and I think I've heard that before. I think it's the session. I don't know if it's something with your mic or not. Did anything change?
It could be that I'm moving around a bit. Let me try and stay a little more still and talk a little bit more to the mic.
Okay.
Actually, I think I know what it is. I'm going to just switch some slides around for a minute, so apologies, things are going to look a bit crazy for a few seconds. Let me see if I can fix this right now.
Okay.
That, Because if I have it as I had it, because away from the mic to talk.
Okay, are you talking now?
Sorry, to look at.
I was just checking to see if you were talking.
Get this working.
It sounds good now.
Sounds good now. No, that's not what I want. Oh. That's better. That's what I wanted. All right, now the screen that I'm looking at is also the one that my mic is next to. Sorry, I think I kept having to look away to look at my screen, which meant I was looking away from the mic. So let's try that again. So Perfmon counters. Point 4 is where I got to. Some of the Perfmon counters have got slightly misleading names. This is more a case where they've got similar names. Multiple counters will have similar names, but actually monitor very different things. So before you start looking at a counter value, make sure you know what it does. There is a description option in Perfmon. You can click on description and get a 2-3 line summary of what the counter means. If that's not clear, hit Google and look up online. Lots of people will have explained what the counters do, what they are, what they mean. It's far better to spend 10-15 minutes browsing Google than it is to draw a conclusion, draw an incorrect conclusion from a counter that means something that means something different to what you thought it meant. That's the high level on Perfmon counters. These, and I know it's a very long list, and I know I'm breaking every rule of slides at this point. This is for anyone that wants to take a screenshot. These are some of the counters that I will look at when I'm looking at a badly performing server. Just quickly go through them. The available megabytes is how much free memory there is. If that is low, for loose definitions of the word low, then I could be looking at memory pressure from Windows' level. If that's high, I could have a case where SQL isn't being given as much memory as it could.
Gail,
Yes.
one other request. Can you make your screen larger? It's about half size on the slide. It was fine. Okay.
Is that better?
No, actually, we see nothing now. There we go. Perfect, perfect, perfect.
Right, okay. Right, sorry. When I switched the screens around, I didn't switch which one it was presenting off. Right, so Perfmon counters. Sorry, I guess I should have cleaned a bit more of the technical stuff up before we started.
Oh, that's okay.
Well. So available megabytes is going to give me an idea how much memory is free, as in not used by Windows, not used by SQL Server, not used by other applications that are running on the server. General rough rule of thumb there is you probably want to see that in the vicinity somewhere around 800 megs to a gig. And yes, that was very, very rough and lots of caveats. It's not a problem if it's higher. It does mean that maybe SQL can use more memory. If it's really low, Windows might be trying to get the other applications to reduce memory. But it's something to look at. More what I'm interested in when I look at available megabytes is I want that stable. I wanted a flat line. I don't want that going up and down all over the place, because if it is, it means that memory usage on my server is not consistent. Something else is running. Maybe it's SQL, maybe it's something else. But there's some fluctuation in memory on my server, and I don't like memory fluctuating very much. Okay, processor user time percentage, that should be fairly self-evident. That's the average percentage use time across all of the cores in the server. You will never see this at 100 unless you're looking at a single core server. I can't remember when I last saw a single core server. I can't remember when I last saw a single core machine, for that matter. Because of the way multi-core processors are scheduled, this will never reach 100. If it's sitting in the vicinity of 95%, consider that maxed out. Again, I'm not looking for good or bad. What I want for the processor is to get a feel for whether this server is potentially CPU bottlenecked or not. Are we sitting at 20% CPU? Are we sitting at 80% CPU? Where in the line are we? How much of the processor is being used on the server? How much headroom is there? Physical disk. Average seconds per read, average seconds per write. This is the average disk latencies. On average, if Windows issues a read command to the drive, how long does it take to return? These values should be low, really low. 50 milliseconds is damn good. Anything below that's probably great. Anything over a couple hundred is probably really bad. This is one that does actually have quite a hard threshold. If you see these sitting at 300, 400 milliseconds, you've got some serious drive latency problems. The question of why the drive has high latency is entirely another problem. It's not going to tell you where the problem is, it's just going to tell you that you probably have slow reads or writes. The next few, full scans a second. That's the number of full table or index scans that SQL does per second. This one doesn't have a good or a bad value. I'm going to use this when I look at the weight stats later to judge whether I have too many table scans, whether I've got poor index usage. Lazy writes a second and page life expectancy combined help me determine whether SQL is under memory pressure. So the memory available megabytes was whether Windows was under memory pressure. The lazy writes and the page life expectancy are going to give me an idea whether SQL is under memory pressure. Oh, and by the way, if anybody has heard that page life expectancy should be no lower than 300, please throw that out right now. It's an archaic rule. That was a good value back when we had servers with 2 gigs of memory in them. These days, my phone has more memory than that. Moving on, lock wait time, lock waits a second. Again, no good or bad values. I'm going to use these when I look at waits to try and conclude whether there's excessive locking and blocking on this server. You will always have locks. You will always have lock waits. It's not a problem that they exist. It's only a problem if they become high for individual sessions. SQL's memory manager, total and target server memory. Total is how much SQL has. Target is how much it wants. I don't really care what values these are. I want them flat lines. If the target server memory is bouncing up and down, it means that Windows has been telling SQL to reduce its memory usage and then letting it take more memory. You do not want that. SQL should be keeping a consistent memory usage. Windows should not be coming under memory pressure. So again, these two, I want them flat lines. I don't really care what they are. They should be close to what max server memory is set to, if max server memory is set. Lastly, the compilations and recompilations per second. These give me an indication whether the plan cache has been, the plan cache is being used efficiently. Again, it's an indication of memory pressure in a sense, but also whether perhaps we've got unparameterized workloads, whether we've got inconsistent workloads. These aren't going to say anything by themselves, but they can be very useful later for trying to see what's going on with the server. For example, a server I looked at middle of last year. Particular query was fast for about 15 minutes and then slow for about 15 minutes, fast for about 15 minutes. And this pattern repeated all day. And we couldn't figure out why. It was fast, slow in intervals multiple to about 14, 15 minutes. Then we had a look at the compilations and realized that the compilations per second was so high that no plan was living in the plan cache for more than 15 minutes. The entire plan cache was getting replaced virtually every 15 minutes, which meant when our query was getting recompiled, it was getting compiled with different parameters and causing our fast, slow query problem. It would have been really hard to figure out what was going on if we hadn't also had these values and been able to look at the compilations and seen just how high they were for this particular server. So that's Perfmon. And these are not the only counters I look at. These are my core ones. I will add other ones as I feel, often based on what problems I've been told the server is having. Steve, do you have any technical questions at this point, rather than complaints about my slides, my screen?
No, actually, there weren't very many complaints at all. It was me who didn't like it, but I guess
Cool.
there are some questions, and even though you're saying that there's no bad and good values, there are some questions as to, okay, there are some places to where you give general guidelines. Is there any place that any website or blog or any particular user blogger that actually keeps up with, okay, these are the more current things, these are things that are general guidelines you can use? And
No.
there's about 3 or 4 questions related to that.
I can't think of any. This is probably an area where you're going to go and read up on each counter individually. I'll give you some guidelines as to numbers. As I said, seconds per read, seconds per write. You'll probably find that guidance on probably an MSDN blog. And it's for those, it really is lower the better. If you've got sec per read, sec per write of 2 milliseconds, excellent, phenomenal, fantastic. The higher they are, the higher your disk latency is. There's no point where I can say cut it off at 25 milliseconds and call it bad. The lower it is, the better. The higher it is, the worse. You've got a sliding scale there. Page life expectancy, go read Paul Randall and Jonathan Cahias's frequent comments on this particular subject. They have lots to say on it. Page life expectancy measures the average time that a page lives in cache, and that's the data cache. Worked out a different way, you can look at it as the interval in seconds between, well, sorry, let me try this again. It's roughly the time in seconds for a complete replacement of the cache. So what we're looking at, if I've got page life expectancy of 900 milliseconds, that means when a page gets read in, it's going to live in cache maybe on average 900 seconds, which means that I'm on average replacing the entire data cache every 900 seconds. Whether that's good or bad depends on the size of the data cache. If I've got a SQL Server on one of these old servers with 4 gigs of memory in it, 900 seconds to read 4 gigs of memory, sorry, 4 gigs off disk, not too bad. If I've got a modern server that's sitting at half a terabyte of memory, I'm replacing half a terabyte off from disk into memory every 900 seconds. That's probably a hell of a lot more of a concern. So those are the ones that kind of have thresholds where you want to start worrying. Page life expectancy, the higher the better. Average sec per read, sec per write, the lower the better. And that's, yeah. If page life expectancy is sitting at 5, you definitely have a problem. If it's sitting at 5,000, I can't say. It's going to depend on a lot of things. Yeah, just go hit Google and go through each of them individually. You'll either find people have said things or you'll find nothing. Unfortunately, a lot of that is going to be sifting out the people who actually know what they're talking about from the people who are writing stuff. Never mind.
Okay.
That does not answer the question, I know. I'm sorry.
Well, there may not be a real answer to the question, but you gave some good guidelines, which is and some places to find more current guidelines. We have a question here where the user wants to know, is there a minimum or maximum time frame you should run the Perfmon to get a good look at the counters?
I like to run it for 2-3 days. The default of 15 seconds is decent for our overall profile. It does mean you're going to miss the spikes, but to be honest, spikes aren't that much of a concern. I'm more worried about sustained values than spikes. Perfmon's very low overhead. I'm quite happy setting this up and letting it run 2-3 days, even a week. I'd say 24 hours is absolute minimum. You want to get a full view of the server for a day at least.
Okay, we've got a couple of, okay, one person was asking, are there any third-party tools you would recommend for monitoring these?
Shameless, well, Promotion, advertising, I try not to do this too much. I like Redgate SQL Monitor. I'm pretty sure Tom would kill me if I didn't mention SolarWinds. I haven't used that one personally, but I've heard very good things about it. I have used SQL Monitor. I like it. I've also heard a lot of people say very good things about it. I haven't used any others, so I will rather not say anything. I will say I'm not a fan of SCOM. In case that wasn't clear, I'm not a fan of SCOM. It's useful, but with SCOM, and just to be clear, this is Microsoft's operations manager, you spend most of your time removing nonsensical alerts. It's probably fine once you've got the alerts tuned, but you're going to spend a lot of time turning off meaningless alerts, which means that you need to know what you're doing in the first place, which if you've got a monitoring tool, yeah, it's one of the catch-22s, so not a fan of SCOM. But yeah, Redgate, SQL Monitor, SolarWinds, both very good. I don't know if SQL Sentry's got a monitoring tool out. I can't remember. If they do, it's also going to be very good.
They do.
In general, that company.
In fact, I was going to say there's a couple of different people that have recommended some, and SQL Sentry is our sponsor, so I would be amiss not to go ahead and say something. Their SQL Sentry Performance Advisor has a good section on performance metrics. This was a user sent this in. It has a table of all metrics and has a table of metrics and useful descriptions. So, and then Idera's got some stuff. There's quite a few out there.
But don't know too much about Idera. Paul and the SQL Skills people work with SQL Sentry, so their stuff's going to be very well done. Mm-hmm. Grant, Steve work with Redgate to make sure their tools are accurate. So that is also good, and Tom with SolarWinds. So you've got tools with specialists looking after them. That's definitely going to be good. I can't say a thing about Idera. I've never used it.
I haven't
and I'm going to refrain to say anything about the other ones.
Okay.
One more question if you have one.
Okay. We'll move on. Let me see. This was a question early on. A user asked if a customer has a SQL data warehouse data or SQL Server management data warehouse data set up. Would you use that, or is it worthwhile?
If they had it and they were willing to let me look at it, I might well use it, but I'm still going to set my own metrics up because I want this particular values I want. I might take the Perfmon counters from a monitoring tool if they have one, and I've done that before. I can't remember which one they had, but they just extracted the Perfmon counters from their monitoring tool. And that's fine. For the weight stats and the stuff that I'm going to talk about from now on, I'm going to run my own because I know what I want. And I don't always know what the monitoring tools are collecting. Some of them have a bad habit of aggregating counters or that kind of thing. I don't like that. Perfmon, yes, sure. Other things, no, I wouldn't. Okay, moving on. Oh, one thing I will say, while you're hitting Google and reading up on the counters, if you run across a blog that says X should never be greater than 1,000, where X is a Perfmon counter, ignore that blog. It probably, either the author made a mistake or they don't know what they're talking about. Generally, you don't want to look at blogs which have hard values because most of these things do not have hard thresholds. Just some advice for filtering out some, shall we say, less. I'll try and be polite. Filtering out blog posts written by people who maybe don't quite know as much as they make out. I'm treading on thin ice here, so I will carry on. Moving on to weight stats. These are SQL Server weight stats. Very important here, I do not look at OS weight stats raw because it's completely pointless. The SysDM OS weight stats DMV, which records the cumulative weight statistics for a server, by default accumulates them since SQL Server started. Unless it started an hour ago, that means that those aggregated values are pretty much going to be nearly impossible to work with, because you don't know what's happened in the interval. You don't even necessarily know how much of an interval it is. There could have been index rebuilds, there could have been bulk loads, there could have been atypical behavior. You just don't know. Looking at the aggregated wait stats over 7, 8, 10, 15 days and trying to conclude something is pretty much pointless. So what you want to do when you're looking at wait stats, well, what I do when I'm looking at wait stats, since this is a session on how I do my performance tuning, I will set up a SQL job that logs the wait stats to a table on a defined interval. 15 minutes, 30 minutes. Might even go for 10 if I want high granularity. Probably no shorter than 10, probably no more than an hour. And I will run this for a day or two. Probably over the same interval that I run the Perfmon counters, because then I have matching values. Because what I want is to see what weights were accrued in an interval, because that lets me go and look specifically at what was happening in that interval so I can get some meaning to my weights. Make sure you ignore the meaningless weights. There are a lot of weight types which are expected, which are normal, which have no meaning when you're doing performance tuning. There's a lot of system processes which will be in a wait state by default because they're not doing anything. The checkpoint process is an example of this. When it's not running, it's sitting in a state of checkpoint wait, or checkpoint sleep, sorry. So if the checkpoint activates every, say, 30 seconds and runs for a second, then in a minute interval, it will have accrued 58 seconds of checkpoint sleep wait. This is not a problem. This is expected, this is normal. So when you're doing wait stats analysis, make sure you filter out the nonsensical ones. Glenn Berry, his diagnostic queries will have a good list of the meaningless weights, the ones you should probably ignore. You'll find other blog sites that have them. Most people tend to copy from one another. Glenn's a good source. If you're going to post the wait stats up for somebody else to analyze, for example on the forums, make sure you filter out the meaningless ones. There's nothing more annoying than somebody posting, these are the top 10 weights on my server, and every single one of them is background processed or meaningless weight. So yeah, that's useless. Try it again. Make sure you filter out the ones that don't mean anything. Again, same as the Perfmon counters. Make sure you understand what each weight means. Some of them are badly named. Some of them are badly advertised. People will say that they're bad when they're not. Let me just show you some code first, quickly. Steve, you can see this?
Yes.
Yes, you can. Good?
Yes, good. Now it's good.
Yeah. Okay, so this is the query that I will use in a job to store the weight stats into a table. The weight type, the number of weights that have occurred, the highest wait time, the signal, and the resource. All right, so these need a little bit of explanation as to SQL's execution model. When a query goes into a wait state, let's say it's waiting for a lock, it accrues wait time. When that lock becomes available, the process is signaled, at which point it starts waiting for the CPU. It's now waiting for a slot back on the CPU. While it is waiting for a slot on the CPU, it accrues signal wait time. So your signal wait time is the amount of time that processes have spent after the resource became available before they started running again. The wait time, MS, from OS wait stats is the total time from when the process went into a wait state until it gets back on the CPU. So the wait time includes signal wait time. So if you want to see what was the resource wait time, how much time the process spent waiting for the resource, you need to take the difference of the two. Wait time minus signal wait time, so I store that in my table as the resource wait time. This is probably too short a list. To be honest, I need to go and add some new weights, especially since SQL 2012, 2014 added additional weights. I think this is mostly 2008 era. But this I will put into a job, and I will have it running every 15 minutes, 30 minutes. I'll decide that when I look at the server. It depends on the kind of activity it has. And I will run this, let this job run for at least a day. 2 days is good. Same time period as I'm running my Perfmon counters. Once this is finished, and I take this table, oh, and please do your performance analysis off the production server. Take your table somewhere else and do your analysis. This is the kind of query I use. It's not that complicated. What I'm doing here is subtracting one interval from the next. So I have weights which were recorded every 30 minutes. So what I'm doing here is subtracting the cumulative weight at time 2 from the cumulative weight at time 1. That gives me the weights that accrued in that 30-minute interval. And I've got my signal and my resource. And then I'll just do a pivot and pull out top 10. What this lets me do is see if there were patterns for the weights. So for this particular server, if I was going to try and do some analysis on my locking and blocking problem, I wouldn't do it in the afternoon, because this particular server doesn't seem to accrue lock weights severely in the afternoon. It accrues them sometime between 6:30 and 8:30 in the morning. So if I'm going to do additional analysis for locking, I'm going to go and do it here, because I know I'm going to get data there. I'm also probably going to go and look at what runs between 7 o'clock and 7:30, because something is causing a lot of locking around 7 in the morning. And it's something that doesn't run in the afternoon. Could be I've got overnight processes that are running into the daytime and causing severe locking. On the other hand, if I'm going to go and look at what's causing my page latch problems, my page IO latch problems, sorry, I can do that any time of the day, because while it is higher here, I've still got good, very high values for the rest of the day. So this is a kind of query I will use to pull weight stats, and it also makes it very easy to pull it into Excel and do some graphing, because clients like nice pretty graphs in their reports. To any of my clients that are listening, no, that was not an insult, that's just a comment. One other comment, it was on the slides, I didn't talk about it. All servers have weights. It's a side effect of SQL's execution model. You will always see weights. Be careful you don't misinterpret them. This is the kind of query I see on some blogs. This is pulling the percentage of weight. So what this query is doing is trying to see which weights are which weights constitute the highest percentage. Now, if you were to just look at this alone as is, you might conclude that this server has a severe locking problem, because 41 or 40.5% of all weights have been locked. The problem is, this is my desktop that has been up for 2 days, and I've run about 5 queries on it. And I've accrued a grand total of 20 seconds of lock weights in 2 days. So if you're going to use the types of the queries which have the percentage columns, please don't use them alone. Please don't look just at the percentage and conclude that we obviously have a locking problem here, when we have actually got virtually no weights at all. You need to look at the numbers. You need to look at the numbers in interval. If you want to look at the percentages as well, that's fine. If I could put percentages here and it would be fine, because I've got the numbers, I've got my intervals. I know I'm looking at a defined interval. I know I have very high numbers. But if you're just looking at percentages alone, it can be very, very misleading. Okay. That's weight stats. Very high speed look at weight stats. Steve, any fun questions?
Okay, let's see. This one's a good question. Why is it important to distinguish between resource and signal weights when doing performance tuning?
Why is it important to distinguish between resource and signal weight? Okay, let's give an example here. A query wants a lock. There is an incompatible lock being held, so it cannot get that lock. So it goes immediately into a wait state as a resource wait. It is now waiting for the lock. Let's say it waits 100 milliseconds. After 100 milliseconds, the incompatible lock is released, and this query that is waiting for the lock is signaled to say, you can have that lock, you may run again. It spent 100 milliseconds waiting for a lock. It now has the lock, now it goes into the runnable queue. It is waiting now solely for a slot on the CPU. Let's say our particular server is CPU bottlenecked, and we don't have any spare CPU capacity, so our query spends another 500 milliseconds waiting, not for the lock, because it's got the lock, waiting to get back on the CPU to do something. If I was to look at my total wait time, that would be 600 milliseconds. If I don't distinguish between resource and signal wait, I could conclude that I have a blocking problem because a query waited 600 milliseconds for a lock. But it didn't. It waited 100 milliseconds for a lock, and then it waited 500 milliseconds for a slot back on the CPU. I have a CPU problem here. I don't have a locking problem. So if you don't distinguish between the two, you're potentially going to end up assuming that you've got locking problems, latch problems, page I/O latch problems, when actually you're running short on CPU. So it's very important to keep the two separate. They are not the same thing. If you want to know more about SQL's execution model, SQL 2012 Internals by Kaylin Delaney. Excellent book, lots of detail on the execution process in SQL. It'll talk about the waiting queue and the runnable queue, and show you what all where resource weights are accrued, where signal weights are accrued, and why they're not the same thing. Happiness?
Yes. Well, there's a few here. This one, I think I know the answer, but it would be a good illustrative point for everybody else. The question is working with DMVs giving more details on performance issues than performance counters? I think it's just a different view of different things.
It's a different view. The Perfmon is not going to give me my wait stats. Perfmon is not going to tell me that I have waits for page I/O latch X. Perfmon is not going to tell me what kind of lock I'm looking for, whether I'm looking for shared locks or AX locks or that kind of thing. So this is different information. You can't get the information in wait stats you can get in Perfmon. You cannot get the information in Perfmon that you can get in wait stats. Two different views onto a problem.
This one I've wondered about, and I think I know the answer too. If you've got multiple instances running on the same server, does that affect the wait stats that you need to look at?
No, I will tune each server individually. I'll tune each instance individually. Each instance accrues its own wait stats. You might see things in the wait stats which are caused by other servers. Typically, there'll be CPU bottleneck. You could have memory problems. It's something you need to keep in mind, but you look at the wait stats separately and then ask yourself, are the high wait stats of this caused by the fact that I have other instances? And remember, instances you can separate instances, you can separate their memories, you cannot separate their CPU easily, and you cannot separate their I/O at all. So you've got multiple instances on the same machine, share I/O, share CPU. You can separate their memory. You can kind of separate their CPU slightly. I/O is a lot harder. So it's something to keep in mind. If you're seeing, say, evidence of memory pressure from Perfmon, from the weight stats, ask, are the other instances on the server perhaps consuming too much memory? It's something to keep in mind, but no, I'd look at the same weight stats no matter what.
Okay. What about clustered environments? Does that affect weight stats?
Clustered environments do not. You'll see some additional weights regarding the cluster stuff, but no, I wouldn't worry too much about it. Unless I'm actually diagnosing a clustering or availability group problem, I'm probably going to mostly ignore the cluster-related weights. I'm typically looking for badly performing queries. The typical problems I work with are my system is slow, my queries are slow, my application is slow. So no, for that, I'm probably going to ignore the clustering. It's relevant to keep in mind, but no, I wouldn't look at the weight stats any differently.
And this is a question about a specific weight stat, and I know it probably wouldn't be something normal to bring up here, but it shows up everywhere. CX packet, if you want to talk about that.
Okay, see second last point. Understand what each weight means and what it doesn't mean. CX packet is the poster child for this point. CX packet does not mean problem. CX packet tells you that you have queries running in parallel, full stop, end of story. That is all it tells you. Because when a query runs in parallel, let's say we've got a query and it parallels onto two threads. Those two threads run the query, that's fine. SQL also spawns a third thread, which is the controller. The controller immediately goes into a CX packet wait because it's waiting for the two working threads to finish. So as soon as you see CX packet, you know one thing and one thing only. You have got queries running in parallel. That's all you know. Most of the time, I frankly don't care about it. The only time I'm going to worry about CX packet, let me just switch back to my weight stats. And these are from a real server, by the way. The only time I'm going to worry about CX packet is when it is the highest or second highest or third highest weight on my system, and I'm seeing this one, and I've gone and done some analysis of my latches, of my latch weight, and I've determined that it's parallel related latches. Oh, and my full scans a second is showing high. Because if that combination of things occurs, high CX packet, high latch X for two specific latches, access method dataset parent being the main one that I look for, and I've got high full scans a second coming out of Perfmon, I probably have excessive full table scans, and those full table scans are running in parallel. This isn't telling me I've got a parallelism problem. This is telling me I have some severely badly performing queries, probably bad indexing, that are running in parallel inappropriately. It's not necessarily a problem with parallelism, it's a problem with my queries. One thing I will do on just about every server, and it doesn't actually matter what CX packet is, I will turn my cost threshold for parallelism up. The default is 5, that is insanely low. It might have been good back in SQL 7, which I think is when it got defined. 50, 40, 30, 70, something higher than 5. To be honest, I've started setting it to 50 by default. What I absolutely will not, under any circumstances, do is look at my CX packet weight and say, oh, I obviously need max stop set to 1, because I don't, because that's just going to cripple most servers. I could rant about CX packet all week. Is that enough, Steve?
Yes, that's enough. And we probably need to go on, and like Gail said, if there's any questions not answered, she can blog about them later.
I'll blog in detail. One other weight I will point out is the page I/O latches. Page I/O latch weights do not mean that you have a slow I/O subsystem. They might. They also might mean that you don't have enough memory given to SQL. They also might mean you've got inefficient queries which are reading too much data. There's a lot of information on these weight stats, what they mean. So again, hit Google, hit the blogs, start reading. SQL Skills is definitely the place to start with this. Jonathan and Paul and Aaron and Glenn, they all write phenomenal stuff on the weight stats. So go read their stuff. If you still don't understand, then read further. Right, so moving on. Virtual file stats, sysdm.io virtual file stats. I treat this the same way I treat weight stats. I want these in an interval. These tell me the I/O load, essentially, on my files. I/O file stats, I/O virtual file stats, tells me the total store, read and write on my files, how much time was spent waiting for reads and writes to complete on the files. It tells me how much was written to the files, how many writes happened and how many bytes were written. What I'm looking for here mostly is to determine whether one of my files has a very skewed read-write pattern. So whether one of my files is getting much heavier reads and writes than anything else on the server. I also want to look at this in combination with where the files are, what drives they're on, to see if maybe high I/O load on tempdb is having a negative effect on a transaction log of a user database. You can also use this as the first step for which of my files do I move to an SSD? Should I have one? Because frankly, you want to move the ones that get the highest read-writes, because SSDs read-write very, very efficiently. So if I've got heavy usage on a particular data file, I might want to move that to SSD just to get the lower latency on it. The one thing you can do with virtual file stats, if you've got your I/O subsystem specs, and by this I mean what kind of IOPS is the I/O subsystem supposed to be able to handle? What's the bandwidth supposed to be? Compare what you're seeing with what they're supposed to be. For example, if the SAN admin told me that I should be getting 4 gigabits a second bandwidth to the SAN, but I go and look at the combination of all of my drives and I'm getting just under 1, I'm probably going to be having a chat with the SAN admin about, is there possibly a misconfigured switch somewhere that's sitting at, for example, 1 gigabit bandwidth? That kind of thing. That's a little bit complicated, but it's something to think about. Again, in an interval, and you're looking at the difference between one interval, one time period, and the previous one. Don't look at the total combination since the server was started. It's just, it's meaningless, frankly. Okay. Oh, definitely need to go on. All right, so this is the last section, and then we'll take questions until Steve has enough. Extended events. By this point, I've got a feel for my server's overall health from Perfmon. I've got a feel for overall what is the server, what are my queries waiting for from my wait stats. I've got a feel for what my file latencies look like, my file loads. What I'm now going to look at is what queries run on this server. Because the whole goal of this is to improve the overall performance of the server. To do this, I'm probably going to end up tuning queries. The wait stats, the Perfmon counters, those were both partially so I can make any configuration changes that I think necessary, but also partially so I know what to target when I start looking at queries. To capture the queries, I want extended events. If anyone's still sitting with a 2005 server, my condolences, you're using Profiler, or should I say you're using server-side traces. Do not ever point the Profiler GUI at a production server, unless you want to crash it. It's very good at crashing servers. If you're using 2008, 2005, you want the server-side traces, there's lots of blogs on that. I'm not going to talk about those. 2008 R2 also probably server-side trace. The extended events existed in 2008, 2008 R2, but with no GUI and a small amount of events. A little hard to work with. From 2012 onwards, however, you should be using extended events. To set up an extended event trace, a few things. Keep the events to a minimum. You don't want to monitor the server to death. It's entirely possible to put so many events on that you hinder the server's performance automatically. Try not doing that. You want a view of the workload on a server. You want an accurate view, and this accurate is why I say I don't want to use the DMVs for this. I don't want to use the plan cache DMVs, because if I've got high compilations a second, or if I've got a lot of recompiles, my plan cache may not be representative of what actually runs on my server. I don't want anything to not show up because its plan got thrown out of cache. So I want to know what was running, how long it took, and so I'm going to use extended events. You don't need to run this for days. I know I said wait stats and Perfmon I'll run for 2 days. The extended event trace, I typically don't run it more than 2 hours. And this is because most servers have a very standard workload that repeats itself through the day. The kind of queries you see running on the server at 10 in the morning are very similar to the ones that ran on the server at 9:30, are very similar to the ones that will be running on at about 2:30 in the afternoon, in most cases. If you're working with a server that has atypical workloads, for example, maybe it's got a particular workload between 8 in the morning and 5 in the evening, and a different workload from 8 p.m. till midnight, then sure, schedule 2 sets of extended event sessions, one for the daytime and one for the evening. You're trying to do the least impact to get the most information you can. You don't need a lot of information, and you don't want to be working through 10, 20 gigs of data to try and do the analysis. I have one client who, if I set up extended events, the session generates about 1.2 gigs of data every 10 minutes. You can imagine I'm not running that event session for 8 hours. I'd have to buy a new drive just to move it back to the office. So the smallest interval you can to get a representative workload of the server. An hour is probably good, 2 hours is probably fine. This is kind of the event session I would use. This isn't the exact one I use, but this is more or less. RPC completed. This is getting remote procedure calls. This is getting stored procedures called by the application. Filter out the really, really, really fast stuff. Duration is measured in microseconds. If anything is taking less than 0.1 milliseconds, I really don't care about it. This is probably going to be selects of constants, select at version, things like that. Not interested, don't care. I want to add the database name and the database ID, just so I can identify if there's, for example, multiple databases on the server with the same stored procedures in, single tenant databases, for example, which one? Because I could have different performance behavior from different databases. Very likely I would have if the data volumes are different. SQL statement completed. This is for ad hoc queries run from things like Management Studio. You'll see this from a few other places as well, but this is a SQL statement that is not in a stored procedure. Again, I want the database ID and the database name. I also want the query hash, because I want to aggregate my queries overall, and I'm going to use the query hash for this aggregation. And we'll talk about that in a few minutes. SP statement completed. Now this event is for statements within a stored procedure. I do not want all of them though. If I've captured a stored procedure with this, I certainly don't want every statement in it to also show up separately. That's why this filter's here. The point of this event with this filter is to capture things like SP execute SQL with a string. This is the kind of pattern you'll get from ORMs in Hibernate, Link, Entity Framework. They call the database with SP execute SQL and the SQL string in quotes. I'll catch that as an RPC completed, but it's very hard to aggregate because I've got a SQL statement, not an object name. And so I will grab the SP statement completed. This ensures I don't get anything that has an object name that's actually a stored procedure in one of the user databases. This lets me catch SP execute SQL, SP prep exec, and all of those fun things, the statements. Standard events, and again, I'm going to catch the query hash. So that's roughly more or less what kind of event session I'm going to use. Write it to file. Don't write the file to a drive with the database files on. Backup drives are lovely for this kind of thing. You want a drive that is local to the server, as in not a remote network share if you possibly can, and you want one that's not used by the database files. Often backup drives, I've written traces to C drive before because that happened to be the best place we had. Right, what I'm going to do with this once I have it, I'm going to aggregate these traces over a known period of time. This is why I take it for an hour or two and no more. I want to know, in, for example, an hour, which queries had the highest aggregate total CPU use, which queries had the highest aggregate reads, because those are the ones that I'm going to address that have the highest impact to the server. Story from a server I had a couple of years ago. Bottlenecked on CPU. The CPU was sitting roughly 75% all day. I did my trace, I did my aggregation, and it turned out that the query, that the stored procedure with the highest total aggregate CPU usage was one that ran for about 50 milliseconds. It had about 35 milliseconds on each execution, and it ran a couple thousand times a minute. And because of the frequency of its execution, it was the highest CPU user of the entire server. We looked at the query, decided it didn't actually need to run that fast because it was essentially returning the same data again and again. The owner of the system implemented a cache in the application for this particular stored procedure, and just based on that, the CPU usage dropped to 30%. And all we did there was move a query that ran in 50 milliseconds to cache. So you're not looking for queries that have the highest individual execution time. That's not important. What you're looking for are the ones that have the highest total overall impact, because tune those and you will have the highest effect on the overall performance of the server. Look at what the wait stats told you. Look at what the Perfmon counters told you. If the server is bottlenecked on CPU, if it's sitting at average 80% CPU, you want to identify the queries with the highest aggregate CPU usage to work with. If you're looking at memory pressure, high page I/O latch weights, low page life expectancy, that kind of thing that suggests that the SQL data cache has not been used efficiently, that the I/O subsystem has been hammered, you're looking for queries which read a lot of data. Look at the ones that have the highest aggregate reads. To be honest, I'll do the same thing if I'm looking for parallelism problems. If I'm looking for things that parallel a lot, I'm probably going to start with things that read a lot of data, because reading a lot of data typically results in the query paralleling. So the Perfmon counters, the wait stats, they guide you as to what kind of queries you're looking for, what you're going to, what values you're going to use to decide which queries you're going to tune. And please don't try to tune everything, because you'll be there all week, you'll be there all year, and you're not going to achieve all that much. The simple matter of the fact is that if you tune 3 queries, you're probably going to fix about 10, because the other queries either were getting affected by the ones you tuned, or the indexes you created for the 3 also help the other ones. So each time you do this whole tuning exercise, pick 3, 5, maximum 10 queries, tune them, tune them, deploy them to production, and repeat the exercise. You'll find a different set of queries at the top. Tune those. This is an iterative process. You repeat this until the server's performance is acceptable. I think, no, I don't have any more. No. So that was roughly what I wanted to show you. Okay, I think that's roughly more or less my tuning methodology. I'm not going into the details of how I actually tune queries. I do that, we'll be here all night. So this is good enough for how I identify what I'm going to be tuning, how I address badly performing servers. Steve, do you have any more interesting questions?
Yes, and this is more informational. People are wanting to be sure that you're going to provide the scripts so they can kind of play around with these themselves.
Well, the scripts, there's nothing fancy with them, to be honest. This one is more or less Glenn's wait stats query. In fact, Glenn's is probably a lot better than mine. So ignore this one, go and fetch Glenn Berry's script. I will blog on this one shortly. I'm not going to post this exact query because actually I kind of took this from the set of queries I use for work. But yes, I'll write up how I do weight stat analysis as a blog, and I will do it within a month or two, I promise. The extended event session was simple enough. Again, what I'll probably do is talk to Tony and see if he wants me to update my performance troubleshooting article on Simple Talk and put this here. So I'll definitely provide the slides. Go get Glenn's stuff. This was an example of what not to do, so I'm definitely not providing this. And this one I will blog on within a reasonable amount of time. I hope is that acceptable?
Oh yes, that's totally good.
Okay. Any complicated questions before I bail and get supper?
Okay, let's see.
Let's take 2 or 3 questions.
Okay, we'll keep it slow. Now, this is not exactly what the session was about, but I've had at least 3 or 4 people ask about this. And they understand that it's a different approach, but they want to know if you didn't have time, you couldn't reboot the server, you couldn't do this, you couldn't do that, and you were just looking at a server immediately, what would you look at first to try to analyze it?
Okay,
I know it's a different thing.
Yeah, so first I will never, ever reboot a production server to do anything. That's why my weight stat analysis always takes differences with the previous time interval. I am not going to go to a client and say, reboot your production server now. It's the last thing I want, to be honest, because doing that is going to wipe a whole bunch of information. If I've got a client that says, help, it's performing badly, fix it now, firstly, I tell them that I'm probably not going to be able to do a very good job on it because it's really, really hard to do that. I will start with the plan cache because that's about the only thing I have. If I don't have time to take extended event sessions and weight stats over a period of time, I will probably go and look in the plan cache for queries with the highest aggregate CPU I/O duration. I'd probably pull the Perfmon counters up and just eyeball them for 10-15 minutes. It's not going to be as good as a day or 2, but it's going to give me at least some idea. By the way, I hate doing this kind of work. I've had it a couple times. It's really, really difficult. I will ask the client why they don't have monitoring and subtly suggest that they rectify this as soon as possible and advertise maybe a couple of monitoring tools for them. But to be honest, I'll be hitting the plan cache for the information there. This is really, really hard. I will say one thing, that will be a hell of a lot easier once people start deploying SQL 2016 because of the query store, if it's turned on. But that is a really, really, really hard problem on the current versions of SQL, especially if the client has decided that they reboot the server just before calling you, because that just throws all of the information out. The problem is SQL doesn't keep history very well unless you ask it to. So if you're trying to work out why are things suddenly behaving badly, you're working with a lot of guesses. But yeah, I'd be looking at the plan cache. I'd probably take Atom Mechanics SP who is active, run that to see what's currently happening, and use those two as best I possibly can. I don't like doing that kind of thing though. It's really hard, really stressful, and doesn't get very good results because I could miss the problem easily.
Okay. What about how does this apply to Azure? Similar?
Ooh,
dramatically different?
Ow. I have no idea. I confess I have barely worked with Azure. I know it's possible to monitor Azure. I know Azure now has extended events. You can definitely get the weight stats off Azure. You can send events, so I'm going to guess the same ones are available, some of the same ones. You can't get the Perfmon counters. But Azure's got a whole monitoring dashboard as well. So I have not worked with Azure, so I'm guessing. And Grant, if he hears this, will probably be talking down to me very loudly. That's Grant Fritchie, by the way. Extended events, probably. Weight stats, definitely. And you can't get the OS weight stats on Azure because you've already got a database, but it has a DMV of session weight stats, so I'd use that one. I think it might have a DB wait stats. I'm not 100% sure. Wait stats I can get, extended event sessions I can get, and then I'll be looking at the Azure query dashboard to see what that tells me. But yeah, you caught me. I don't work enough with Azure to answer that one easily.
That's okay. I've seen a couple of sessions. I didn't get to go to pass this last October, but there was a session I think somebody had on monitoring Azure. So I think it is relatively different. So you have to deal with it in a different way.
One thing I will mention on Azure, the feature set changes every couple of weeks for the better. They keep adding stuff that was not there before. So if somebody's told you X is not available on Azure, go back and check, 'cause it might be now, because they just keep adding stuff to it.
Okay. We don't really have time for more questions because I still got about 5 minutes to talk. But you said you were going to blog about all of this. Do you want to put up a screen that shows all of your locations to where you're blogging, if you have one available, so everybody can get to it? Because I'll send you the questions afterwards.
Now you get to see all of my fun. Yeah, yes, I have fun things in my. There you go. There is my SQL blog. So it will be up here.
Okay, SQLinthewild.co.za.
Z-A. Z-A.
I know, I say that differently.
We're English. Well, we follow the English style here. So yes, it'll be up here, not next week, because I've got a post already scheduled for next week, but I'll write the stuff up and get it up as soon as I can.
Good deal. This was exactly the way I wanted it, because I just find that you can learn so much by seeing the way somebody else thinks about something. And I wanted to try to pick the best minds in the business and try to get them to present it for everybody. Knowing that we couldn't get into all of the details, but we have other sessions coming up, and this is just sort of promotion for us. Erin Stellato will be working on extended events in April, and Jess Borland will be working on wait stats, and she's excellent with that. So be sure and look those up. Think about how you want to do your methodology. Get used to it and pick and choose from different people. Gail's is excellent here. Wanted to mention again that I'm sorry, go ahead.
And if you want to annoy Erin and Jen, tell them I said their stuff's bad. I'm far enough out of the way they can't get at me. They can certainly make nasty noises on Twitter. No, I'm kidding. A lot of us will have different ways of doing it. That doesn't mean the other person's wrong. That just means it's different.
And that's why I wanted to kind of present different ways of doing it and then let people pick and choose what they feel comfortable with. But at least have some type of methodology that you go through. And everybody has somewhat of the same stuff, but it's not exactly the same. Okay, I just wanted to mention again, SQL Center is our sponsor. And instead of giving away a prize at the end of each session, what we're doing is if you come to one of our sessions in January, February, March, at the end of that you're going to be thrown into a big pool with our Down Under presentations, and also here in the United States, and we'll give away $300 to one lucky user. So anyway, next month, haven't mentioned that one, haven't been really well organized today. We're going to have Getting Started, I'm sorry, yes, How to Use Parameters Like a Pro and Boost Performance by Guy Glanster on March the 1st. So be sure and sign up for that. Thank you, Gail. I really appreciate it. Oh,
thanks very much. Good night, everyone.
Oh, Gail. We had at one point, I'll go back and get the exact numbers, but we had something like 420 something. I think it was if it's there, that's the second highest we've ever had. And if it gets close to 440, that was the highest we ever had. So you did a great job. And I think that was
actually over 400.
Yeah, it went up close to 400 by the time it started. So people signed on real fast. I was impressed with it. And the thing is it kept increasing after 11:40, it just people were showing up and it just kept increasing, and that's very unusual. So it was a very interesting talk too. So
Good.
very
Okay, I'm glad you
topical. I
liked it.
think people wanted to see it. Yeah, you take this one. I don't know if you're going to give it anywhere else, but it's a great one. So
I'll think about it. I wasn't planning to, but I'll submit it for some SQL Saturdays.
I think I think people may like that. Now I know some other people have done something like this, but there hasn't been enough of it. I think there needs to be more.
Oh yeah, definitely. No, it's good. I like.
Oh, and there's a
Sorry.
ton of questions I couldn't get to, so I just tried to, if I saw one asked twice in the same way, I would try to use it, thinking, well, there's enough interest on that. But there was a
That's
ton
fine.
of
Just
questions.
you've got my email. Just mail me the full list of all questions,
Oh, good.
and I'll decide what's relevant to be blogged and what's kind of just needs a pointer to
Yeah,
somebody else's post.
yeah. There's a lot of stuff like that. So anyway, I appreciate it, and hopefully we can get another one maybe later on in the year or something.
I'm sure we can. I've got conference middle of the year. It looks like May and June I'm going to be traveling a fair bit.